Good morning students, welcome to the enrichment classes in physics for standard 12th. Today I will be discussing some of the numericals on electrostatics, electric field, potential energy. And for your reference I will give these questions in your assignment link also, and I will try to discuss as many questions as possible. The questions will not be of a very high difficulty level, some of them will be in that category. So basically this class I will be devoting to make you feel comfortable with this particular topic. Let's begin our first question that you can see on the board. There is a charge of 50 microcoulomb that lies in xy plane at a point whose position vector is given as 2i cap plus 3j cap, and that position vector is r naught vector. Due to this charge placed at this point, we have to find electric field at a point whose position vector is r vector is equal to 8i cap minus 5j cap. So this is point, this is origin, this point is r naught vector. Here we have a charge, let that charge be q is equal to 50 microcoulomb, and there is another point whose position vector is r vector. At this point you have to find the electric field. Only magnitude is being asked, so don't bother about direction. So electric field, if this distance is r, electric field at this point E will be how much? 1 upon 4 pi epsilon naught times q upon r square. So basically we have to find this particular distance. That is a simple question. For this point the coordinates x, y, z coordinates are 2, then 3 and 0 because it is in xy plane. The x component is 2, y component is 3. Likewise for this point the components are 8, minus 5. Now you know distance formula, students. So if we have these 2 points, the distance between these 2 points r will be given by the formula under root 8 minus 2, that is 6 square, plus minus 5 minus 3, that is minus 8 whole square, that is 64, and this becomes 36. So this becomes 10. So put the value of r is equal to 10, put the value of q is equal to 50 microcoulomb. 1 by 4 pi epsilon naught is 9 times 10 to the power 9. You will get the answer in SI system, and you can see what the answer, which option is correct. So on solving you will find this expression for electric field gives you the value 4500 volts per meter. So our fourth option D is the correct answer. So let's see the next question. Let's see next question. Here there is a charge which is placed at origin. So this is our origin. Charge q is placed. There are 3 points A, B and C where the electric fields are given as EA, EB and EC vectors. 2 statements are given. First, EA vector perpendicular to EB vector. Second, EB is equal to 4 times EC. And then regarding these 2 statements, there are 4 options. Only one is correct, both are correct, etc., etc. You have to judge the truthfulness of these 2 statements. So 2 things we have to do. First, you have to see the directions of EA vector and EB vector. Now what is point A? Point A is 1, 2, 3, and point B is 1, 1, minus 1. These are the 2 points A and B. If this charge is positive, we assume this charge to be positive, then the direction of electric field due to this charge at point A and B will be like so. At A the electric field will be away from this, and at B the electric field will be like this. So this is our EA vector and this is our EB vector. Direction. Now this direction I can say is along RA vector, and this direction is along RB vector. Now what is RA vector? RA vector is I cap plus 2j cap plus 3k cap. And what is RB vector? That is I cap plus j cap minus k cap. Now to see the truthfulness of this particular equation, EA will be perpendicular to EB if these two directions are perpendicular. That means these two directions are perpendicular. We know, students, if these two vectors are perpendicular to each other, their dot product must be 0. So what will be their dot product? Let's check it out. Their dot product will be product of x components, that is 1 into 1, product of y components 2 into 1, product of z components, that is 3 into minus 1. So 1 plus 2, 3 minus 3, it comes out to be 0. Since it is 0, first statement is correct. That is, EA vector must be perpendicular to EB vector. Now we have to check for the second statement. For this, you need to find the value of EB and EC. How to find EB? EB is the value of electric field at point B, this is point B, due to this charge. So you know the formula for electric field, 1 by 4 pi epsilon naught multiplied by that charge divided by this distance square. Now how much will be this distance square? This distance square will be difference of x coordinates square, that is 1 minus 0 square, that is 1 square, plus again 1 minus 0 square, plus minus 1 minus 0 square. So this gives the value 1 plus 1 plus 1, that is 3. So this becomes 3. I am not putting other values. Likewise, EC will be 1 by 4 pi epsilon naught Q upon RC square. Now what is point C? You can see 2, 2, 2. So RC square will be 2 minus 0, 2 minus 0, 2 minus 0 squares. So it becomes 2 square plus 2 square plus 2 square. How much will be this? 4 plus 4 plus 4. That is 12. So this becomes 12. This is clearly 1/4 of this one. So I can write EB is equal to, see this part is same, 1 by 4 pi epsilon naught times Q. So 1 by 3 is 4 times 1 by 12. So I can write this is 4 times EC. You can check it out. If you multiply 4 here, 4 and 12 will cancel, 3 will be left. That means we are getting EB is equal to 4 EC. So our second statement is also correct. Now you can easily choose the option. Option C should be correct, which says both 1 and 2 are correct. Is this solution clear to you, students? I hope so. So let's proceed for the next question. Let's see third question. This is the figure given. The question reads like this: two identical point charges are placed at separation of L. P is a point on the line joining the charges at a distance x from one of the charge. At P, the electric field is E vector at this point. You have to choose one of these graphs which is the correct description for E versus X graph, where X is the distance from one of the charges. Now see, this electric field is due to this charge as well as this charge, their superposition. So what will be the net electric field versus X graph? You have to choose 1 by 1. See, first thing, at the midpoint, so this point is L by 2. L by 2, this is L by 2, this is L by 2. At the midpoint of this line joining the two charges, the electric field must be 0. Because this charge will have electric field, this charge will have electric field, both of them will be having same magnitude and opposite direction. It is 0 here, 0 here, 0 here, but it is not 0 here. That's why this option is not correct. It is slightly above the x-axis. Being 0 at all the three graphs, now we have to choose some other criteria. Let's see just at the vicinity of one of the charges. Here the net electric field will be due to this charge, which will be in this direction, and due to this charge, which will be in opposite direction. But this charge is away from this point, so its electric field will be small, much small compared to this particular electric field due to this particular charge. Since this point is very, very close to this charge, the value of electric field must suit up at the locations of points which are very close to this charge, because electric field is proportional to 1 by r square. Now for point which is very close to Q, R is very small, so 1 by R square will be very large. That gives you a hint that electric field just near this charge must be quite large. Electric field just near this charge will also be quite large, because this charge will dominate, the distance is very less. But here the electric field will be large and it will be in this direction, away from this charge, and here the electric field will be in opposite direction. When I say electric field, I mean net electric field. Since the electric fields are changing the directions at these two ends, therefore the signs of electric field must change after the midpoint. Before midpoint and after midpoint, the signs of electric field must change. That's why this graph is wrong. Out of these two graphs, now as I told, here electric field must be very large. That is reflected in this particular graph. Here this becomes asymptotic line. So this graph actually will become almost parallel to electric field, will touch to this graph, this axis at infinity. On the other hand, this graph suggests that it is having a finite value. So out of these two graphs, this one is correct one. That is the fourth one. So our option number D is correct representation for the variation of electric field versus x, where x is the distance from one of the charges. So at the center it is 0, and at the location of either of these two charges, the electric field has very high value and the directions of electric field are opposite. That's why if you take one of them in one dimension as positive, the other one becomes negative. So option D is the correct option. Let's see the next question. Okay, let's see next question. There are 2 point charges Q and 4Q. You have to find the position and value of another third charge, capital Q, such that the entire system of these two and this third charge achieves equilibrium. So the question is, what charge capital Q is needed to achieve equilibrium for entire system? Entire system means this charge 4Q and the capital Q charge. And you have to also find the position of this capital Q charge. See, equilibrium means net force must be 0, and because it is equilibrium of the system, net force must be 0 on all these 3 charges. If this charge happens to be here, whether positive or negative, these two are identical in the sense of their signs. If this is positive, this will be positive. If this is negative, this is also negative. So either both of them will attract or both of them will repel if we put this charge Q here. So net force on this Q can never be 0 if it is placed to the left of first charge Q. Likewise, if it is placed to the right of 4Q, both these charges will either attract or repel. For equilibrium, one of the forces should cancel the other force. That is possible only if this charge Q is placed here. Both of them will attract or both of them will repel. So if these two charges are attracting, so the forces will be like so, they may cancel, and if they are repelling also, they may cancel. The only possibility is in this particular region. Next, we have to see its position. Clearly this charge must be placed close to this Q. Let this distance be x. Then the remaining distance will be L minus x. So for Q, its equilibrium demands, if this charge Q is at equilibrium, the net force must be 0. Force on this charge due to this Q will be how much? 1 upon 4 pi epsilon naught Q upon this distance square, and will be in one of the directions, and opposite to that direction will be the force due to this charge, and its value will be how much? 1 by 4 pi epsilon naught Q times 4Q upon this distance square, L minus x whole square. Now this gives you a simple equation, students. 1 by 4 pi epsilon naught will cancel, Q will also cancel. So what is left behind is this 1 upon x square is equal to 4 upon L minus x whole square. Solving this, you should get two values of x because it looks quadratic. The x will have two values. I will not solve it. You take a square root, this will give you 1 by x is equal to 2 upon L minus x with plus and minus sign. Cross multiply, you will get two answers for x. So you will get the value of x. In all the options it is L by 3, L by 3, L by 3, L by 3. So there is no need to find also x. It must be how much? L by 3. But I suggest you to please solve it and check it out. Next thing that we have to find. We have found the location of this point. Next we have to find value of this point charge. How much should be capital Q equal to? To find its value, we will consider equilibrium of any one of these two charges. I will assume equilibrium of small q. Now for equilibrium of small q, net force on small q should be 0. Now think, suppose this q is positive, suppose this 4q is also positive. If capital Q happens to be positive, then all the charges will repel each other. This charge can never be at equilibrium because this will repel in this direction, this will also repel in the same direction. So in order that this small q be at equilibrium, this charge must be negative. Then this will attract and 4q will repel. You might ask, why did you take this positive? Don't take. If q happens to be negative, 4q will be negative. In that case, q happens to be positive. What I mean, capital Q must have opposite sign to that of small q. If q is positive, this has to be negative and so on. Now how to find the value? Net force has to be 0 on this particular charge. We are discussing its equilibrium. Force on small q due to capital Q will be how much? 1 by 4 pi epsilon naught, which I write as k, times product of these two charges, q times capital Q by this distance square, that is x square. Force on this due to this charge will be 1 by 4 pi epsilon naught times q times 4q upon that distance square, that will be how much? L square. Now x we have already calculated, x is how much? L by 3. So this becomes L square upon 9, 9 will be shifted to the numerator. Now in this question you can see k will cancel, q, small q will cancel, capital Q will not cancel, L square will cancel. So capital Q becomes how much? 4 upon 9 times q, and I have discussed q must have sign opposite to small q. So I must put here negative sign. If q is positive, this will be negative. If q is negative, this has to be positive. Now you can see which option is the correct option. So L by 3 is in all the options, q is minus 4 by 9. So this option is the correct option for this particular question. Okay, let's see next question. Okay, here we have next question. The question goes like this: you have to find the direction theta of net electric field E vector at point P. This point is P due to uniformly charged finite rod. This is uniformly charged rod, finite rod. These two angles are given at this point P. We have to find the direction of net electric field. Remember students, I have discussed earlier that if this be a finite rod, at some point the electric field is in such a direction that it has two components. One is E perpendicular and second one is E parallel. E perpendicular is the component perpendicular to the rod, that is Ex here, and E parallel is the component parallel to the rod, that is Ey here. So here Ex, which is the E perpendicular component, that will be how much? You should remember that expression, k times lambda upon this distance. Let this distance be r. K lambda by r times sine theta 1 minus sine theta 2. Now what are theta 1 and theta 2? This angle corresponds to theta is equal to 0 degree. So these angles are theta 1 and theta 2. And then I have discussed that we must take the mod. Directions will remember, if the point is above the midpoint, the Ex and Ey components will be like so. If it is below the midpoint, they will be like so for positive distribution of charges. For negative distribution of charges, it will be just opposite. And likewise, the E parallel component will be how much? The E parallel component is Ey, that will be k lambda upon r times mod of cos theta 1 minus cos theta 2. So you don't have to bother about the signs for theta 1, theta 2 because we have to take the modulus. Directions will be like so. In this particular question, now see, this is theta 1, this is theta 2. So one of the angles, that is this one, is how much? 60 degree. This is 30, so this has to be 60 degree. So theta 2 I will put as 60 degree. Theta 2 I will put as 60 degree. What is theta 1? Now which one is theta 1, which one is theta 2? You need not bother because we have to take modulus. The other angle you can see is 0 degree. Because this point is just over here. This line corresponds to theta is equal to 0 degree. It is like this. So we don't have to go above this line. So theta 1 will put 0 degree. Now putting these values, what answer will we get? So this becomes k lambda by r. Sin 0 will become 0. Sin 60 becomes root 3 by 2. And then you have to take its mod, so it becomes only root 3 by 2. Cos 0 becomes 1. Cos 60 becomes half. So it becomes 1 minus half, that is half, and its mod will be how much? Half. So into half. Now we have to find this angle theta. It's clear that that angle tan theta, tan of that particular angle theta is y component by x component. That is Ey upon Ex. Now what will be Ey upon Ex? If you divide these two, k lambda by r will cancel. We will be left with half upon root 3 by 2. So 2 will cancel. We will be left with 1 by root 3. What value of theta satisfies this relation that tan theta is 1 by root 3? So theta must be equal to how much? 30 degree. So our first option is the correct answer to this particular question. Okay, let's see some more questions. Okay, let's see next question. In the next question, we are given two rings which have a common axis. Their centers are O1 and O2. These rings have radius r each. Separation between the centers of the rings is also equal to r. Charges Q1 and Q2 are distributed uniformly on these two rings. So the rings are identical except for the charge on them. The charges are different. Now a small test charge, small q, is brought from one point to the other by an external agent. The question is to find the work done in moving that charge q from O1 to O2, from one of the centers to the other centers. And these are the four options given to you. Now the work done in shifting a charge from one to the other point is given by this formula. Work done is equal to charge into potential difference. Now here we are bringing the charge from center O1 to center O2. So I will write the potential final, that is at O2, minus potential initial, that is O1. I have used the concept that work done is equal to, by external agent, the work done is equal to charge times potential difference. So our task is now to find VO1 and VO2. Now potential at O1, this is the O1 point. Here potential is due to two things, due to the first ring and due to the second ring. Due to the first ring, the potential will be 1 by 4 pi epsilon naught times this charge upon this radius, that is so. See, if you have a ring at the center, how to find the potential? This is the actually formula for point charge. But if you choose an element, potential due to this element dq at the center will be 1 by 4 pi epsilon naught dq upon r, and then we will integrate it. Since r is constant, the integration of dq will give you total charge, that is q1, plus you have to find potential at O1 due to this charge also. So due to this ring, the potential will be 1 by 4 pi epsilon naught, which I can take common, times this charge upon this distance. Because if you choose any element, that element will be at this particular distance. If you choose an element here, so this is in the form of a ring, and on its axis this point O1 is lying. So all the points on the ring are at equal distance. It forms a cone-like structure. That distance will be how much? Pythagoras theorem you can use, root under this square plus this square. Now this is r, this is also r. So root under r square plus r square will be the answer. Likewise, potential at O2 will be how much? Let's see quickly, 1 by 4 pi epsilon naught. At O2, due to this ring, it will be Q2 upon R, and due to the first ring, it will be Q1 upon root under this distance. That is again root under R square plus R square. Let's see how much we get. R square plus R square is 2R square, so we'll take the square root. We'll be left with root 2 times R. Here also we'll get root 2 times R. So we can get 1 by 4 pi epsilon naught and R as common. What is left behind? So you can take common here itself, R. So Q1 plus Q2 by root 2. Here also we'll take R common. So Q2 plus Q1 by root 2. So these are our potentials. Therefore work done, this one, will be Q into VO2 minus VO1. So this minus this, when you will do, you will get this term as common, 1 by 4 pi epsilon naught R. This minus this. So Q2 minus Q1 plus Q1 by root 2 minus Q2 by root 2. Now this is the answer. Now this I can write as, I can take minus sign common, and then this becomes Q2 minus Q1. Now in this Q2 minus Q1 and Q2 minus Q1 I can take common. So this becomes 1 upon 4 pi epsilon naught R. This Q will be there times Q2 minus Q1 also I will take common. Okay, no problem. If you take Q2 minus Q1, what will be left behind? 1 minus 1 by root 2. So this becomes root 2 minus 1 upon root 2. So this gives you this option B, I think, as the correct answer. There is Q, there is root 2 in the denominator, there is 4 pi epsilon naught R, and there is root 2 minus 1. Now you might think, here it is Q2 minus Q1, here it is Q1 minus Q2. So here I have taken the work done in shifting the charge from O1 to O2. That's why we are getting this. It's not mentioned in the question whether we are taking the charge from O1 to O2 or O2 to O1. So if you take it from O2 to O1, it will be just VO1 minus VO2, and you will get Q1 minus Q2. That's not important. What's important is this factor, root 2 minus 1. Here it is root 2 plus 1. So this option is not correct, this option is not correct, because it is root 2 plus 1. This option is not correct. The only correct option is option B for this particular question. The next question is based on this particular figure. The question is like so. In a space of a horizontal electric field, this is the direction of electric field towards left, and its value is given E is equal to mg upon q. That uniform electric field exists as shown in the figure. A mass m, small m, attached at the end of a light rod. This rod is massless. At its end there is a mass, small m. It has some charge, small q. Length of this rod is L. If this mass m is released from position shown in the figure, that is from this particular position, at an angle of theta, where theta is given how much? 45 degree. You have to find the angular velocity of the rod when it passes through the bottommost position. At this point, what is its angular velocity? And its 4 options are given, out of which you have to choose one. See students, on this particular object, what are the forces? One is gravity, which acts in downward direction, like so, and one is electrical force. If this charge is positive, then that force will be in this direction, like so, and both these forces are constant force. These two forces, the electrical force as well as the gravitational force, are conservative in nature. That is the essence of this particular question. Since the forces acting on this particular mass are conservative in nature, the total mechanical energy initially and finally must remain same. Our initial point is this, which I name it as say P, and I'll call this point as O. So total energy at P must be equal to total energy at O. Now the total energy can be written as sum of kinetic and potential. At P, clearly the kinetic energy is 0. Kinetic energy at P plus potential energy at P must be equal to kinetic energy at O plus potential energy at O. So kinetic energy at P is 0. Now potential energy at P, there are two conservative forces. One is gravitational potential energy, other one is electrostatic potential energy. Gravitational potential energy here at this point I can write like this, is given by mgh. M is its mass, g is acceleration due to gravity, and h is this height. Now if you see, this is L, so this particular length and this particular length you can find easily. This is L, so this is L cos theta, and this one is L sin theta. I want this h. So h is nothing but this total length minus this length. This total length is L and this one is L cos theta. Subtracting them will get this distance. So L minus L cos theta, L I can take common, this one. So this is gravitational potential energy at this particular point. There is one more potential energy, that is electrostatic potential energy. So electrostatic potential energy I'll write as EL, EL for electrostatic, is equal to kinetic energy at O. At O, the kinetic energy is half mv square, which I can also write as I omega square, plus potential omega is what we have to find. Potential energy at O. Now the gravitational energy, potential energy at O, we can take it as reference to be 0. This is 0 gravitational potential energy, height is 0. So the only potential energy here at this point is due to electrostatic forces. So potential energy at O due to the case of electrostatics. I am repeating again, kinetic energy is 0 here. Potential energy has two terms, one due to gravitational force, one due to electrical forces. At this point, kinetic energy is half mv square or half I omega square. Potential energy is not due to gravity, it is due to electrostatic potential energy. Not due to gravity, I am assuming this level as a 0 potential energy level, then that would be correct. I have to find this, so I will keep that one side, half I. I is moment of inertia of this mass, that is nothing but mass times this distance square, that is L square, and then we have omega square is equal to mg into mgl times 1 minus cos theta plus up minus uo due to electrostatic. So electrostatic potential energy difference is this factor. This is the change in electrostatic potential energy between points P and O. So as this charge Q comes from this point to this point, the change in potential energy can be written as, this term will become actually Q into change in potential, Vp minus Vo. Is it clear, students? So this becomes equal to mg, I'll first calculate this part, Vp minus Vo. Now how to find this potential difference? I am finding that potential difference first. Vp minus Vo is equal to, by definition the potential difference is given as minus integration E dot dr from initial point to final point. Now here initial point is O, final point is P. Now see, this is, we are finding Vp minus Vo, okay, it's okay. Now if you see clearly, if this point is O, this point I write as O dash, can you say that O and O dash points, these 2 points are at same potential? Why? You see the direction of electric field. Electric field is towards left in this direction, like so. We know that electric field is always perpendicular to equipotential surface. So this line lies on a plane like this, which must be perpendicular to electric field lines. So electric field lines are like so towards left. Therefore, all the points on this particular line which is perpendicular to the electric field must be equipotential. So potential at O is same as O dash. So O I will replace by O dash. So this becomes O dash. O dash to P you have to go. O dash to P. So while moving, so dr vector will be towards right, but electric field vector is towards left. So the dot product will be negative. That negative and this negative becomes positive. So what will be left? E is constant, so E will come out of the integral. And what will be left is integral dr. From where to where? This point to this point. This point to this point, integration dr is nothing but this length. What is this length? That is L sin theta. Let me repeat again. I am moving from, first I argued that points O and O dash, because this line is perpendicular to the direction of electric field, both these points must be at same potential. Please look over to equipotential surfaces when I have discussed. So instead of O, whether I bring the charge from P to O or P to O dash, there will be same difference in potential energy. So O I have replaced by O dash. By definition, this is given by this formula. Now I am moving from O dash to P. While moving from O dash to P, I am moving in a direction opposite to electric field. So this dot product becomes negative, cos 180. So the cos 180 and this minus sign becomes plus. We are left with integration E dr. E being constant comes out. We are left with integration dr. Integration dr from this point to this point is nothing but L sin theta. So this is potential difference. Now we are ready to solve this question. So Vp minus Vo I will write as E times L sin theta. So this becomes E times L sin theta. This is Vp minus Vo, and there was charge Q. E is given in the question. E is how much? mg upon Q here. So E I will write as mg upon Q. So let's see what do we get. So what we have to find? Omega. You see m, it will cancel. Now theta is given 45 degrees, so cos 45 becomes 1 by root 2. Sin 45 also becomes 1 by root 2. GL we can take common. So what is left behind? You see 1 minus 1 by root 2 plus this Q and this Q will also cancel. So 1 by root 2 will be GL I have taken common. So this cancels. So what is left behind is GL, and here we had half L square omega square. Now we have to find omega. So omega square will become 2 will go here, L square will come here. So one of the L will cancel. So omega square is 2g by L. So omega will become under root 2g by L. That is this particular option, option number B. So that is the angular velocity at this lowest point when this charged particle is released from rest from this particular position. So this question we have invoked law of conservation of energy, and that we could do only because the two forces acting on this charge are both conservative in nature. Students, I will stop here. I will suggest you strongly to practice as many questions as possible given in the assignment link. Many of these questions in assignment I have already discussed. This will help you in sorting out your problems for the rest of the questions. I thank you. All the very best. Try your level best.